chapter, I mean, kind of, quite honestly, the first two chapters of geometry are very wordy, if that makes any sense. There's not as much math as there is like vocab. Remember, we started in section 1.2. And in section 1.2, that was that first step into what everything looked like. How did we draw diagrams? It had basic definitions for geometry stuff, where it was, points, lines, planes. What did it mean to be collinear? What did it mean to be coplanar? Non-collinear, non-coplanar, all those little bits and things that we had. And for the most part, that first section is generally pretty straightforward. There's not, intersection, what does it look like to be the intersection of two planes? Well, they can intersect and they create a line. The intersection of two lines can be a point, or they can be the same line. Things like that. How do you label a ray? Well, the endpoint's always at one spot and it goes through another spot. What do opposite rays create? It has a lot of little bitty vocabulary that as soon as you guys started to see the diagrams of the pictures themselves, you're like, oh, that kind of makes sense because you can visualize it a little bit more. It's almost kind of like your first step into geometry, becoming a visual math thing, where most of the times when you guys are solving algebra problems, you're looking at this, what is that? It's just a formula, right? But once you start to think about, for example, the distance formula, knowing, get out of here with the limitation. Let's go. Let's see it. When you get going in here and you start thinking about what distance formula really is, when you have the distance between 2 points, when you measure it, you always measure something in a straight line because you don't measure things that are on curves because it's not the same length. If I measured from here to here, the way that works is that there's some distance moving from left to right. There's some distance moving up and down. So the distance formula creates, if you start to think about it, it's nothing more than the Pythagorean theorem. So if you can visualize, I know this is a horrible looking thing, but if you can visualize points in space via just a graph if you have to, and know that you're drawing a right triangle, and that distance is always becoming the hypotenuse, that's where the visuality of a really crappy looking algebra setup comes to life. So yeah, this is awful. But if you start thinking of something you guys already know, because you guys learned Pythagorean theorem back in what, 7th grade or so? When you first talked about triangles, I think? That sound about right? Yeah, somewhere in there. I know a lot of people learned about it. You've never heard of it? Oh, okay. I know they talk about it in algebra. I know that for certain, but a lot of times they talk about it earlier just to get you an idea of what you're going to get. Like in my Algebra 2 class right now, I'm showing them certain values within the coordinate grids, or your XY grids, of why things are going to happen in 4 months. So just to get like a preemptive strength, if you will, of the knowledge you're going to see. So you learn about how you can visualize material in a different setting. That was kind of the big thing in 1.2. There wasn't really math there. Actually, I'm about to sneeze. I had to move the sneeze, so I take it back. 1.3, 1.4, and 1.5 was all of the algebra. It was all about the different stuff in, this all had segments, segment addition, it had segment bisectors. If I say segment bisector, remember that means the same thing as the midpoint of a segment. We did that algebraically a lot before we got to the coordinate thing. There's a little bit of a difference there. We talked about angles. We had, is it right if I put it up to here for now? So we have a little room. We had angles. We had angle addition. We had angle bisecting. but those were depending upon the information that they gave you in a problem. You knew whether or not you had to set them equal to each other, two smaller sections add up to equal a whole, two angles add up to equal a whole, two angles that are equal to each other. You had all that bits of information, and if you remember, as long as you knew what the vocabulary meant, it was very simple to set up the algebra. And our algebra steps were really never any more than 2 steps, really. I mean, you might have had an extra variable on the side, but in essence, you didn't have to square both sides and take square roots and do a lot of crazy stuff. So you had angle bisectors. And then it also got into the vocab part of angle pair relations. And what I mean by angle pair relations, it's when we had complementary, supplementary, linear pairs, and vertical angles. Those were the 4 types of angle pair relationships that we talked about. And knowing which one you had was knowing how you would set up your problems. For example, if I say you have supplementary angles, what do they have to add up to equal? Perfect. They got to add up to 180. Therefore, complementary add up to equal 90. Remember the really stupid way to remember that? C comes first. 90 comes before 180. Okay. What's that? Get the backwards P. Yeah. Or, you know, you've got to turn 90 degrees before you turn 180 degrees to face the other direction. You don't understand that? Stand up. Oh, hey, what's up? When you get a chance, I'll take the homework. All right, turn 90 degrees to your right. Turn 90 degrees to your right. Now turn 180 degrees back. Aren't you where you started? Turn 180 degrees. Isn't that 2 rights? Turn left twice. Turn left 90 degrees twice. Isn't that the same thing as 180? Yeah. So go right half of 180. Okay, make 3 lefts. Those are right. Yeah, so now which way did you turn? Oh, you turned right. Go right 3 times. Which way did you go? You went left. You don't understand? Say it up. Seriously, think about it. I mean, just because it's funny, if I'm facing this direction, and then I turn right once, twice, 3 times, what direction am I facing? Left. So don't 3 rights make a left? And then 3 lefts make a right. See, you guys don't know this yet because you haven't really been driving in a city. A lot of times you get driving into a city, you got your parallel perpendicular grid lines for streets. And a lot of times they're one way. You can't turn left on a lot of one-way streets, but you can turn right. So you have to go right to go back to the left. It's a silly thing that I just like to make. I like to just goof around with people like that. But yeah, that's all that is. That's what that is. It's directions. All right, anyway, angle pair relationships. So we have complementary, supplementary, linear pairs, and vertical. Okay, so complementary angles, like we just said, are 2 angles that add up to equal 90. So I will say angle plus angle equals 90. Or I will say that angle plus angle equals 180. Okay? That's what we look at when we're talking about in terms of complementary angles or supplementary angles. Now, on the quiz, I asked that you guys draw an example of a linear pair. What does that look like? Well, think about the definition. The definition of a linear pair is what? What do they do? They make a line, right? So we know that two angles have to form a line. These are a fancier version of supplementary. Because do supplementary angles or complementary angles have to share the same vertex? No. They just have to add a 90. It doesn't matter where they're placed. So if I look at linear pair, we know it's going to be two angles that create a line. Well, there's a line. There's only one angle, right? All I have to do then is just draw a. That's a linear pair. Two angles that create a line. The difference between that and what most of you guys did, when you saw vertical angle, when you saw linear pair, you thought this. That's a vertical angle. Vertical angles are the ones that are opposite each other, share the same vertex, that are congruent. Okay? Can you have congruent angles that form a linear pair? Well, they both have to measure 90. They have to measure. You should know this. You just turned 90 degrees a bunch of times. What's that? What a timeline is? All right. So, excuse me. When we're dealing with things like this, remember, guys, it's the idea that you have to understand where vocabulary comes into play in order to know how to set up an algebra scenario. Right? Now, when we looked at these linear pair stuff earlier, we had stuff that looked like. Let me get an example here real quick. Then with the PDF file right where it says the chapter. Now, one of the things that's different about this PDF file, if you notice right on the top it says chapters 1 and 2 PDF. That means this file itself is 100 some odd pages long because it's 2 chapters worth of information. What's that? What do you mean? No, you shouldn't have to do that because we'll use it sparingly. I'm going to try and continue to use the new textbook. This is where a lot of the new materials are coming from. There are times I like going back to the old textbook, and if we ever have to, it'll just be the same way where it'll be a PDF file on the calendar. You won't have to save it. I'll just send you the link every time. All right, so it's not a big deal. Now, one of the things that if it's saying page 60, as you page down, you notice how it's telling me that now we're on page 5, 6, 8, 10, 12, whatever. Well, if I go for a little bit, and now it says that I'm on page 39, but look what page number it is in the textbook. Page 39 in the PDF file is page 17 here. So what you're looking for is page 60 on the textbook, not on the PDF format. Okay? Does that make sense? I'm looking for page 60 out of the textbook. So I just keep scrolling. Yeah. And this is where the actual review stuff starts. Okay? So it's just a little bit different. Don't go by the page 60 via the PDF file. Make sure you're going by page 60 on the textbook. That's why I wanted to make sure I showed you that. It's only going to be like that for chapters 1 and 2. And then when we get to chapters 3 and 4, page 60 on the PDF file could be page 300 in the book. So no matter what, you're always going to have to look for the page number in the book. Does that make sense? I didn't think you guys would. I've done this before with the PDF files when we didn't use this textbook last year when I posted things like that. People were doing the wrong pages all the time because it didn't occur to them that page 60 wasn't the lesson that they on the PDF file, wasn't the lesson that we did in class that day. Then you ask people, did you take notes? Did you write anything down? They're like, oh. So do you think you're going to be successful in doing this stuff? No. I know this looks like there's a lot of problems, but what you'll notice real quick as you go through them, they're super fast. This really shouldn't take 1 to 20 minutes, tops. Okay? Try and knock out as much as you can for this evening, 1 through 31. And then tomorrow we'll hit some little questions that you come up with, and then I'll pass back those quizzes and go through those things with you as well. And then I have a couple extra things that I'll get you for as far as a little bit more review is concerned. Yes, ma'am. Yeah, go right ahead. He's back. All right. Questions? Knock yourselves out, figuratively, but not literally. You push in, I'd be impressed, but don't do that. It's not nice. Yeah. So we're gonna now, and then we're just gonna go over it tomorrow and see how we did. You'll be surprised that a lot of this stuff, it's super straightforward. Yes, sir. Oh, it's on the things. It's 1 through 31. It says they're on the calendar. Yes, ma'am. You'll be done with this super fast. I mean, another name for line G. Well, how do you label lines? You need 2 letters with an arrows over it. So line G, I find it can be XY or YZ. It's super fast. It should be super, super, super quick. All right.